at the end of the session. So I wanted to introduce Mr. Tim Conway from the SANS Institute, and he's going to be talking today about business risk to critical infrastructure. Thank you.
All right, good afternoon, everybody. I'm going to go mask off and kind of hover around here. If anybody wants to talk afterwards, I'll go mask on, so don't be afraid. Thanks for joining us. We are going to go through, we have about an hour, and I don't know everybody in the room, so I don't know your background. So we're going to do like one slide, two slide on some general terms and some basics, and then we're going to race into some case study and get into some defense approaches and some different things to think about. Case study we're going to talk about here is the Colonial Pipeline event, and kind of walk through some of the IT and OT differences. So for those who are kind of brand new to all of this, if you think of information technology, you can think of information technology kind of in normal sets of data. So data in motion across a network, data at rest sitting on a server storage database, and data in use, so something in a process or an application or in memory space. When you think of OT, operational technology, kind of shift your thinking to data that does something, meaning it's something, it's got a kinetic component, it's a representative of a state of something in the field, so a sensor, temperature, position of a valve, position of a circuit breaker, or it's something that can manipulate the state of something in the field, so it can operate, so open a valve, close a valve, start a motor, move a product. As you think of IT and OT in those two areas, in those two ways, I know in a number of classes that we've had, people have heard terms like SCADA and ICS and DCS, and they're trying to understand where they fit. So we kind of created this slide, thinking about kind of the top cyber physical technology, kind of that bridge between when you're thinking of OT, operational technology. Going down one domain into industrial control systems, that's generally where you'll find kind of the supervisory control and data acquisition. So for large, wide area operations, whether you're in large grid operations for electric power or natural gas pipeline, interstate, or large water facilities or manufacturing, SCADA is normally where you would find that, meaning an operator sitting at a screen and we're presenting data to them. That is their source of truth, of what kind of that distant process looks like that they're in control of. So they'll see that data acquisition, the DA side of SCADA, the data coming and being presented to their operator screens. And then when they need to take action and manipulate that process, that's the supervisory control element of SCADA. Within kind of those plant operations, you'll see distributed control systems, so you'll hear those referenced as DCS. You'll see small scale kind of manufacturing or chemical that are PLC based, so programmable logic controllers. If you walk out here and take a left and go to the SANS booth at the end, you'll see some of our programmable logic controllers that we have on the table that we use in our courseware. Safety instrumented systems, those most are not super familiar with, but they are designed and engineered to safe the process, either protect the humans working at that facility, protect the community that the facility is in, or protect the equipment. They're not used for operating. They're not used to bring a unit up or bring a unit down or move a process. They are there for safety specifically. So if you've heard of the Trisis event, going after the Triconics controller in the Middle East at a petrochemical facility, seeing adversaries manipulating a safety system should be concerning to everybody in the room, whether you're in industrial control system, cybersecurity or not. Just knowing that adversaries are working down that path, the only intent to go work on a safety system is to cause equipment damage or human loss of life. So when adversaries are testing code and testing capabilities in a safety controller, it's for one of those two things, and neither one of them are good. As you look at the traditional instrumentation and control, those are the people who do work on the process environment and kind of that level where the sensors and actuators are. Moving over into some of these other categories where I'm not going to be talking today, so I won't go through each one of them. Categories of kind of home or building management or automotive or aviation, where you see more CAN bus technology and home area networks and other things. But definitely that's where you'll see some of the IIoT and the automation grouping. In the single purpose, that's kind of like wearable technology, implanted devices, infusion systems, pacemakers, those kinds of things that have sensors that are looking for certain signaling and then they take an action. Again, there's a whole domain of study there of manipulating those devices to cause harm. That, again, should be concerning to everybody in the room. As you think about where these things are, they're everywhere in your world, so kind of everything you interface with all has industrial control system components. Traditionally, the electric power side, so nuclear, and bulk power, so transmission and generation, those are the areas that have gotten a lot of focus, because when there's a problem, it's a problem that happens fast. So power flow across our electrical interconnections, that is moving speed of light. So kind of 200 miles a second. When there's a fault, that will cascade across an interconnected electric system. So we have lots of cybersecurity focus there. Looking at electric transmission and generation, and other nations looking at the same thing. Now, as we've sort of moved our fuel supply into natural gas and away from coal, now you're starting to see a lot of focus on an attack against natural gas pipeline interstate is an attack on the power generation system. So those two things are leaning on each other like dominoes. As a result, you're seeing a lot of interest in stuff like the Colonial Pipeline event. You're seeing the Biden administration moving forward with actions from Dmzs CISA that regulation will be coming in regards to reporting events and cybersecurity requirements and assessments. You're also seeing indications of that coming for water and for chemical and for rail and other transportation. So just thinking about that from a scale perspective on water, one cybersecurity requirement for water, there's 55,000 different water entities across the US alone. So you start to think about the number of people that need to understand IT, OT, operations, engineering, and cybersecurity. We are going to have a very, very quick shortage on people that understand those different topics. So I'm glad to see the folks here in this room. If you have an interest in those types of areas, certainly you talk to us at our booth out there from a training perspective. Or if you have the skill sets and you're looking to do consulting work, we kind of have community forums where people are hiring for that specifically, that skill set. As you look across all these other domains, control systems are a part of every single one of them, including the buildings and the building management systems where you work. All right, those were the general slides before we move into some of the case studies. We're going to walk through a ransomware case study that impacted kind of the IT side, so I'm saying that with air quotes to the degree that I can, but it impacted the operational elements, and that is kind of the elephant in the room question that many people have asked. So ransomware hit Colonial on the IT side, why is there no product moving down a pipeline if it wasn't an OT-specific attack? So we're going to talk about those kind of areas in between and where they exist in other sectors and kind of the lessons learned from Colonial specifically. Then we will talk about specific OT ransomware cases that we have been doing in some of our courseware and in some proof of concept capabilities that we've been looking at. So ransomwaring at a controller level, at an operator HMI level, and how difficult that would be to recover from. We have some that we've sort of done on operator human-machine interfaces that the ransomware is in and doing full firmware recovery, you can't get it out. So without knowing specifically where the backdoor key is on that HMI or in the programmable logic controller, you throw it out and you hope you have enough inventories and spare so that you can get your process back up. I assume most are familiar with the Colonial event, but just quickly, so largest refined products pipeline in the US, about 100 million gallons of fuel across 5,500 miles of pipe, and 280 different facilities across this pipeline, from terminal stations to storage stations and everywhere in between that they are getting those products out. On May 7th, Colonial Pipeline shut down its operations due to critical systems impacts on their IT side. This is kind of 5 days after the operational event. They started pipeline operations. Is there anybody that is from Colonial or familiar with pipeline operations in the room? You're with Colonial? All right. Okay. So the line was still packed with product. So when they started it up, they could move it to certain terminal stations where they hadn't manually operated. But in general, it is moving at about 5 miles an hour from the pickup stations in Houston, and you are going a long distance. So before this whole thing was lit back up, it took some time to move that product across. By May 13th, they were commencing delivery in most markets, and by midday, it was kind of up and operational everywhere. Over time, a lot of these different 280 different pumping stations and pressure stations, they have moved to cyber digital assets. So moving away from the ability for somebody to just come in and do manual controls and manual operations. And that is the trend across every industrial control system environment. So 40 years ago, if some systems died at a power gen site, a number of the instrumentation and control engineers could sort of jumper around some things and bring that unit back online. Those capabilities, that ship has sailed and sunk. It is all digital assets that you really need to have people that have this combined skill set in order to kind of support those environments and bring them back online. That was the case here. The CEO of the company kind of testified in Congress and specifically called that out, that they had some people they brought in from retirement to kind of go and walk some of the elements and try to do some manual startups, but it's getting harder and harder for them to do any of that and sort of operate this entire system without all of their digital assets that were potentially impacted. As this came out, so FBI released a compromise identifying Darkseid Ransomware. CISA and FBI released a joint ransomware advisory. Some comments from CISA in regards to not getting information in a timely manner. And I worked in electric power generation, transmission, distribution, and control, and in natural gas interstate pipeline across 14 states, as well as local distribution, storage, and port facilities. I was in that role for about almost 16 years. I can tell you, working with the intelligence community, the message we always received is a call to one is a call to all. So we looked at all of our incident response plans, and we had notification to local FBI, state FBI, and counted on them to sort of socialize that information out. We had some regulatory requirements to report up to ISACs, information sharing and analysis centers, depending on the sector. But the main effort was to notify and then focus on recovery, focus on safe operation, focus on service to customers, not contacting every single law enforcement organization that exists across the government and USG, allow them to socialize that information. So kind of some of these concerns and some of these reports from government kind of saying we're not getting information we need, that was concerning to us on the asset owner side. We don't have time to go notify every single US government organization. Talking about Darkseid Ransomware. So this is ransomware as a service. Those who have not been exposed to it, kind of two different approaches. So a tool set and an affiliate program. So people kind of doing initial compromise, getting an initial foothold, and then loading in this tool set to exfiltrate the data and then encrypt the data set. So you have two approaches in these ransomware attacks. One of them is if you've encrypted the data and the target doesn't care. They say, whatever, we'll just recover, we'll get our operations back. Now you also have their data and you can release it out unless they pay a ransom. So a number of people paying because they're more concerned about the data being released than not. In this case, they paid the ransom, the $4.4 million, but they still had to do a breach notification to all their employees where their PII information was lost and everything else was potentially compromised. Even though it wasn't publicly posted, it was still visible to some other organization, so they had to report. Operates with affiliates. They claim no geopolitical kind of affiliation. Most would attribute kind of Revel, Darkseid, a number of them all to Russian-affiliated organizations. Because this event, I believe, took this organization, Darkseid, by surprise, meaning they were going after the IT side. They were going after data sets. I don't believe they intended that the largest liquid gas pipeline operator would shut down operations and it would become a whole of government effort response. So they immediately started posting things out to the web in regards to they're going to pay closer attention to who their affiliates are targeting and making sure that they're not going after critical infrastructure, because I don't think they were looking for the people in this room and some of DOD to raise their flag and get their attention. I think this was meant to be purely criminal, but that is where the fog of war comes in, is you can't really ever tell based on where it's coming from, what is their intent. Are they criminal in nature? Are they trying to steal information, or are they trying to understand operations so they could come back with a future attack? Becomes very difficult. FireEye released a report on Darkseid, also very interesting, kind of walking through what they've seen, but again, understand these are their affiliates. So different skill sets, different tradecraft, different tools that the affiliates might use. So this is kind of what they've seen from being used in initial compromise to establishment to escalating privileges, internal reconnaissance and pivoting, and then ultimately using the tool set to do the encryption and handle all the payment on the back end. In current news, so FBI continued to follow the money, and they were able to recover about $2.3 million of what was paid and bring that back to Colonial Pipeline. There's one question that I do not have the answer to, is number one, why they didn't get the full 4.4, but from the time they paid the 4.4 to the time they recovered the 2.3 is when Elon Musk kind of made some comments about Bitcoin and, you know, the impacts to environmental for all the power consumption of Bitcoin mining, and Bitcoin's plummeted. So I don't know if they recovered it all, but the value plummeted because of the statements that were made. So the timing I don't know if they didn't get the full 4.4 because of that reason, or they got it all, but the value was less. They were able to bring back 2.3 to Colonial. Before we leave ransomware, any questions on general ransomware before I go into more of the kind of IT/OT discussion? As you have questions, just raise your hand and shout them out. I'll try to repeat them because they're recording the session. All right, so from an asset owner entity perspective, this was an unbelievable thing, meaning the CEO of Colonial came and testified willingly in a public forum and started walking through the case study, why they decided to pay the 4.4 million ransom, what the recovery efforts looked like. He was very, very transparent. They were asked questions about, do you work with this government organization? Do you do these assessments? And he was very transparent in kind of what they do, how they've done them. I've been kind of on the other end participating in those for some of our facility walkthroughs. And they also kind of acknowledge that they pay for assessments to be done to their operational environments. A couple of things. So he also called out the initial access was through a compromised accounts that were on the dark web that the adversary or the affiliate grabbed and was able to then use, and specifically connected in through an older legacy VPN that was single factor that they weren't even tracking anymore at Colonial. So when you think of these like multi-state companies and remote access and all the different facilities that people pop into, the interconnectedness of it all from environment to environment, that is needed for SCADA, that is needed for data exchange, it's needed for billing and for interface with customers. You have tentacles and connections all over the planet. They had moved everything to kind of a common central hub, remote access, multi-factor. Our organization went through something very similar where we had 48 different points of internet connection that we tried to isolate down to 3. And they had gone through the same thing. They had an older legacy point of connection that they weren't tracking anymore, so when they would do an assessment, they would turn over their documentation to the assessment teams. The assessment teams would go and do the assessments, but no one was ever tracking this. They were never doing a blind assessment. What can you find? They were doing here's the borders. Here's our network, here's our physical, here's our logical, go do an assessment, and they did exactly that. So all the assessments that they had done from third parties and working with government, none of them ever looked at that point of access. Their main components in the delays and restoration were kind of focused on ensuring that they had appropriate integrity of their system before they started pressurizing the system, which with that amount of pipeline, there's volunteers going out and doing physical inspection, there's flyovers, there's a lot of things that have to happen before you feel like the integrity of the pipeline is good from a physical perspective, and then you can start to actually test it, and now you're looking at the integrity of your cyber assets, which that could be a very, very long process. Outside of SANS, I do work with Department of Energy, and I was in some of the response actions in Ukraine 2015, 2016, and a number of the other former Soviet countries. And when you're looking at the level of compromise that occurred in some of those assets and trying to say, when do we have the integrity of the system that we can bring it back online and start counting on it, it is a long, long process. Even without an attack, you go buy a system that you know, love, and trust from your vendor that you married, that is a 2-year process to do system specification, factory acceptance testing, site acceptance testing, 1,000-hour performance testing, field point checkout. It is a long process for a system you know. For a system that's been compromised, manipulated, firmware modified, it's multi-year, and if you continue to get an attack during that time, you're never going to get it back. So they were looking physical first, and then starting to look to the operational side of their assets to make sure they had integrity of those components. This is kind of the elephant in the room for those that are in the industrial control system community. You saw a lot of people step forward and say, it's ransomware, it's IT. This has nothing to do with us. But then you had a couple other people saying, but their operations process is completely down. So we got to start talking differently to the community because those two things don't make sense. If it's IT only, meaning back office, HR, legal, file and print servers, why is there no product flying through the pipe? So because people kind of compartmentalize those two things. It's either IT or it's OT, and there's nothing in between. And the reality is there is tons of things in between, and a lot of connections between them. So you look at like public statements. This doesn't go out on a Colonial Pipeline, massive organization website without 10, 12 different leadership eyes looking at it. They did not say this was an IT-only attack. They said They proactively took down systems to contain the threat, affected some of their IT systems, and they halted all pipeline operations. They did not say this was billing only. They did not say this was IT only. So as you kind of think of the Purdue model, and this is a very, very trimmed down version, but where you get down to kind of the sensors and actuators, and you move up to the control elements, and you move up to the operational elements, and then these industrial Dmzs of all the flows back and forth. That is your judo move from a defense perspective, is using those industrial Dmzs to the level that you can. So having an ingress and an egress depending on what it's for. If you're going to put something for remote access in the industrial DMZ, what protocols and how you're doing it. If you're getting data out for a data historian or for billing or for some type of manufacturing execution system, how you build those things in the industrial DMZs is really important. And then how you talk about those. Are those things IT assets or are they OT assets? And they have connections in both directions, north and south. So you really need to kind of put all of your OT stuff on one bookend of the shelf and say, the sensors and actuators, for sure, those are OT. The programmable logic controllers, for sure, those are OT. And then on the other end of the shelf, you can say kind of our Active Directory domains and where we log in every day and our internet and email, those are absolutely IT. But now you've got all this stuff in the middle. This industrial DMZ certainly is bridging IT and OT. And then you're moving into the supervisory control elements, and you have to look at all of those trusted communications paths that you have up to the industrial DMZ and out or back into it. This is really, really important. And oftentimes kind of these utilities that go and testify in front of their different utility commissions and the rate-making commissions, somebody who's a CISO that's talking about everything at that top level, the corporate business enterprise, they will step forward and say, we have antivirus on every endpoint. We have intrusion detection everywhere. We've invested in the latest and greatest whatever product. And then you start asking them, check the box every other layer where you've done the same thing. And most of them don't even know how to answer the question because they have zero visibility into these different facilities and different operational technology environments. So as you're working with customers, as you're working within your own organization, just understand what capabilities and controls you have at each area. And if you have very limited budget, very limited time, focus a lot of effort on the industrial DMZs and where you can clip the communications in and out and track it. As we look back to Colonial, kind of this thing in the middle, they have a whole bunch of pipeline storage, and then they have a whole bunch of pipeline pushing different products across. But they're pulling products in from a variety of different customers. So the Shells, the Chevrons, the Exxons, the various people that are pushing gasoline, home heating oil, jet fuel, diesel fuel, premium gas, lots of different products coming in from these different refinery storage. So on that intake, so some network extensions out so they understand what they're taking, and they have sensors that are pulling that in, and they can track it. On the outtake, they have tons of local terminals where they're pushing and storing these. So from different military bases to airport facilities to just local terminal stations to fill up tanker trucks. So the ins and the outs, and then all the things in the middle, and their connections go in and out. The products that are pushing across. This isn't just like natural gas, where we're pushing molecules. It's not different types of molecules. It's not like electric, where we're pushing megawatts and electrons. There's not different types of electrons. Here, you have a lot of different products that are going through with interface in between this transmix that are separating them. So you may pull from one customer a certain type of product, and then a transmix, and then you're delivering to a different location. If you don't know what is in that pipeline, you're not delivering nothing. You don't want to deliver jet fuel to a gas station. You don't want to deliver regular gasoline to an airfield. So you need to know what it is and track it. And that's not your compressor stations. That's not your pumping stations. That's not your pressurizing the system. That's not your quality of the system. That is what is in the pipe. That's the product. So that's really where you start to get into these work-in-progress systems, manufacturing execution systems that are tracking recipes, that are tracking product, that are tracking quality, that are tracking customer source and customer destination. And if those systems go down, you can't continue to operate. So that's your in-between system. It's not purely IT. It's not just data. It's not because it's taking sensor information from your OT environment. It's not purely OT. It's not controlling pumps. It's not controlling valves. It's the stuff that is being delivered. And that exists in every critical infrastructure environment. So for electric power, you have direct operations that are real-time operations. So you think of 3 different time horizons. Real time, what is load, what is generation, and you're trying to balance that constantly like you're riding a bike. generation, 1 foot on a pedal, load the other foot, and they have to be in sequence, otherwise it stops. So you're constantly doing that in real time. Then you have another time horizon, which is after the fact, so billing and metering and tie-outs. And then you have other time horizons that are planning. So do we need new generation? Do we need new transmission lines, new substations for different kind of subdivisions that are being built or new customers? So those people on the transmission planning side, they're constantly looking at forecasts and real-time analysis and kind of contingency analysis and study networks that they have direct connections into the system to pull real data off the SCADA system. So the paths are there, the trusted comms are there, and we are in kind of a new world now with a lot of job roles and a lot of positions that everybody used to have to go into a double badge multi-factor control center. Now with COVID, you're comparing the safety and risk of doing that job remotely with the safety and risk of exposing an operator to COVID or pandemic issues. So a lot of jobs are being done now remotely that we would have never been okay with in the past across all of these critical infrastructures. And that's going to be that way for quite some time. So kind of the adage, as you're talking IT and OT, there is not that strong separation of, well, we have a perimeter firewall overall for OT assets. You have a ton of communications that are allowed in and out, and if you can get close enough to some of those industrial DMZ assets, you will absolutely be close enough to cause an operational outage. Some of these trends that are continuing to move down that path, cyber-enabled OT devices, where a lot of these used to be electromechanical, serial, analog devices. Again, those are all going away. We're moving for full digital. And as you have those digital sensors and digital components, you are interconnecting them and driving interdependent systems. Those things are moving to the right and increasing risk. Every one of these critical infrastructure sectors are seeing more and more regulatory requirements, a lot more targeted, specific industrial control system attacks. And then the only benefit on this chart from an ICS trend perspective is we are starting to see a lot of industrial control system aware tools. So visibility, detection, monitoring and alerting tool sets that we never used to have in this space. Any questions on the general kind of IT, OT events that happened in Colonial? And then I'm going to talk a little bit about specific OT ransomware attacks. All right. So as you look towards what we were discussing in regards to Colonial, kind of in that industrial DMZ and those manufacturing execution systems or ERP systems where you see that strong tie, there is certainly a capability to ride over one of those trusted communications and get down into the supervisory control area where you have human-machine interfaces and you can manipulate the code set. A number of the different kind of CMOR panel view controls and very, very common operator human-machine interface for local panels that are throughout kind of port facilities, LNG facilities, out in substations or compressor stations for local operation. There are ways that you can manipulate those where you cause a inability to get into the system setting screens, generally to avoid somebody from doing harm. So loading in that code so you fault out the system setting screens and then loading in additional code where you make the memory set persistent, so then even firmware flashing it, it is constantly there, and there's no way to escape out to reprogram it in any other code set. So now you've locked that operator workstation. And if you manipulate the operator screen so they can't use them for anything, it is effectively a boat anchor that can be thrown away. And then you have to pull from inventories. And if you did that at scale, which many of these across kind of these wide area view, they have common loops. So you can get from one substation to another substation or from one compressor station to another, and you can quickly kind of perform that attack at scale. So blinding an operator would be of significance and causing an inability to operate in the field, going after engineering workstations and locking up the known good kind of gold project files would be of significant impact. There is also capabilities to get into the logic and into the project files and lock it there. So even if you still have access to it, getting into it, you wouldn't be able to see it or change it or modify it. And you'd really be more in a re-engineering state, which if you think about what it took to build the plant from an as-operating or from an as-built, and then all the changes that have happened throughout its life to an as-operating, there's a tremendous amount of changes that have happened from the engineering from when it was built to how it's operating today that you'd have to reconstitute and redo it all. So OT-specific ransomware attacks at this level causing a loss of historical data, quality, analytics, loss of control and data acquisition from a SCADA perspective can be very, very significant. And if it's done at any level of scale to any sector, it can be greatly impactful. A couple of other things to talk about is I focused a lot on the industrial Dmzs, and if you see those cannons, that is kind of the trend that has been in place for a number of years in the OT world, is guns out. So put investment in to kind of look at traffic coming from corporate business enterprise environments or from remote access and defend forward, so going that direction. But it's really, really blind to the fact that we have a plant talking to a plant talking to a plant kind of across. Or we have vendors that are direct connecting in at the operational level to do unit performance or maintenance testing or tuning based on warranties. So there's lots of east-west connections within a facility and from facility to facility. Again, kind of in power generation, a lot of east-west from site to site. And in power transmission, same thing. As we've moved to a deregulated market, we have kind of these independent system operators that every single transmission company is connecting to in a hub and spoke model. So lots of connections that are occurring now across electric side and natural gas with energy trading and energy markets as well. Again, if you think of kind of Colonial with its connections to the refineries and connections to the terminals, a lot of those kind of process data sets connecting straight in at an east-west level. Where we don't have a lot of detection, we don't have a lot of visibility, and we don't have a lot of capabilities to respond or contain. Looking towards when the bad event happens for a particular sector or a particular organization. So when we've had an opportunity to sort of do some exercises or competitions with net wars, or we do some work with countries where we're doing country-level exercises across critical infrastructure. In North America, working across GridX, which is about 700 different utilities participating, 8,000 different players that work for those utilities. We do exercises with other countries overseas like Poland and Ukraine and others. As we look towards those, and we often see kind of the teams that have been trained in cybersecurity, they want to do the normal incident response. And in some cases, the asset owners don't ask them to do anything different. They have an incident response plan at the corporate level, and they haven't changed it at all for their operational environments, for their kind of facility environments in any manner. So the normal response is kind of this identify, kind of working through the steps, containing it, and immediately there's a focus on capture. There's a focus on what's the IP address and what do we do, versus moving towards these operational environments and moving to manual controls or moving to control inhibit so that you can operate through the attack and you can continue to produce product and you continue to service customers while you're doing the other things in parallel to find where the attack source was coming. A number of these environments have control inhibit and have manual operation capabilities. It's just a matter of the incident response plans, and people aren't trained to enact those to sort of safe the system as well as they can. Ultimately, if you're working down a path where adversary is in a system, so again, thinking of Ukraine 2015, Ukraine 2016, or the Trisis event, adversary manipulating the system directly. This is an operations problem, meaning everybody who works in operations at these critical infrastructure sites, they have been trained forever. Reliability is the king. Keep the facility up no matter what. And when you start to get into these very specific industrial control system attacks where the system is being manipulated to a point of destruction, meaning it's going to cause equipment damage, it's going to cause human loss of life, it's going to cause damage to load or to customer systems like high-value rotating motors or large water pumps, and on the customer side, steel mill impacts, long-term, multi-year outages. When the system is being manipulated that way, reliability isn't the king. Integrity is the king, meaning you don't want to keep a system up for somebody else who's misoperating it. So the best step you can take is to force an outage. If that's the bridge you've crossed in your incident response plan, that we no longer have control of this system, we no longer have integrity of this system, we need to take it down before it's damaged. That's where Colonial was, and they took it down quickly. While they figured out all the ransomware, while they figured out all the other items, they lost integrity of the system, so they took it down, which means they had planned that. There's not an operator that's just going to come in and shut down a system and hope they get their job the next day. Within electric power, after the August 14th blackout, our CEO and went and signed a letter to every single operator we had and framed it and put it up on the wall that they are ultimately responsible for the reliability of the system. That they don't have 15 minutes to ask, hey, do you want to talk to the customers and tell them we're going to take it down? The system will collapse faster. Again, 200 miles in a second from an outage perspective. So if you're seeing a cascading outage, you have to act quickly. If there's an integrity issue, the operators need to know what their incident response plans of action are, and they need to take those actions so that they can operate through it, and then when they hit a point where the system is being misused and they no longer have integrity, having the ability to load shed and take that system down. On the restoration side, this is a piece that I think we've all seen with ransomware. Yes?
Are these going to be local defenders or companies that hired? Who's going to be deciding this?
Question is, are they local defenders or companies that they hire? So answer is, in industrial control system world, it depends. That is the correct answer all the time. So my job is easy. I just say it depends. But for smaller municipalities, co-ops, and others, there's a strong argument to say there's some benefits for them doing some things in the cloud. There's some benefits for better security, better detection. There's some benefits for managed service where other people are looking at it, and those people are continuously trained, and they're seeing lots of traffic, and they know what to do. They know what bad looks like. So for smaller municipalities and co-ops, that they're not going to go hire 15, 20 people and buy multi-million-dollar systems that now have sensors across all their environments. For smaller municipalities and co-ops, there's an argument that it's external. For larger, mid-size, or investor-owned and operated utilities, there's an argument that it's an in-house capability because you're going to know your system better than anybody. So it really depends on who and what type of system and at what scale it fails. So electric will fail fast, electron flow, speed of light. Natural gas will be a little bit slower, but now that has an impact on generation, so that's probably the next important. Water will be local and regional all the time. So how it fails, so the Oldsmar water attack of manipulating the amount of chemical in the process, that takes days before somebody's consuming it. And I used to work for a water, so you would issue a boil order as soon as you detect it. So at what speed are you looking and finding that, and can you respond? So each sector has a different response and a different impact rate. And then the size of the company itself will vary that answer. No matter what, we need people who are doing it, either working badged for the company or for a third party, and right now they don't really exist. There's not a tremendous amount of them. On the restore and validation side, so we've all seen this with ransomware, so how good are your backups? Have you tested them? Have you validated them? But that really gets into, from an ICS perspective, what are you backing up? So the controllers themselves, the logic in the controller, that's a thing that you're backing up. The state of the data, you're not backing up. So what the values are from the sensors, what the position is from an actuator, or what it's doing in the field, that's not something you're doing in a routine backup. And from an attack perspective, if you set a memory resident bit that is causing an HMI to not display anything, and you've attacked that and caused a loss of view, restoring the known MER file to a panel view, or restoring a file to an operator HMI, restoring the logic, is going to keep that status there because it's in the data side, it's not in the logic side. So what you're backing up and how you can do initialization routines to recover your assets all needs to be very, very well tested. The safety walkdowns, for sure, I mentioned that in regards to Colonial. That was a large percentage of why the delay in startup existed. Is, are we sure we have a physically safe system from a physical perspective, and then are we sure we have integrity of our operational system that we can rely on? The planned startups, those take a very long time, and in many cases you don't get a chance to really test them. So in power gen, you get unit maintenance schedules or you get refueling, and then you can do startups, or you have an unscheduled outage that you have to recover from and do a startup. In transmission, you don't have a lot of that. You're generally working on lines live all the time. So planned startups, in many cases, you are doing a startup and kind of testing your procedures when you're responding to an event. As you look through kind of what we're trying to achieve from an ICS perspective to kind of minimize the impact of a successful industrial control system attack, especially ransomware, especially something that's made to look like ransomware, but it's more a state-sponsored attack, we are looking to reduce these gaps. So as we've responded to a number of control system events, and you kind of look through adversary actions across initial C2, pivoting into the industrial control system, developing capabilities, validating attack, delivering it, and then running it. You look at that time from the adversary actions on the top to the defender actions on the bottom. What things existed that they had to jump over? What existing security controls? What problems were in their way? Any types of perimeter controls specific to ICS? Any hardening actions that have happened within the OT environment, which is rare. You usually get a system from a vendor, and if it ain't broke, don't fix it kind of a model. In power in North America, there is a ton of controls that you have to enforce, so you're constantly interacting with it. But across the adversary actions and the defender, you have these gaps in between of how long, what's the dwell time from the initial ICS compromise to the detection, and how much can you shorten that with additional OT-specific visibility, with OT-specific understanding of protocols so you can do detection or behavior analytics or network whitelisting at an operational technology level. And you can start to shrink that detection gap. If you move into the, now we've detected it, but how do we contain it? We can't simply just start severing control loops to stop an adversary from taking an action, because then we will attack ourselves. We will no longer be able to operate. So where are your points of segmentation that you can actually sever? And how would you do that? So you can make that as small as possible. What are your key essential elements that you can operate from? And how quickly can you bring in spare inventory elements to run from and operate through an attack? The last piece is the remediation. How quick can you recover? Some of that is going to be process specific. Even if Colonial shut down for one day and it was ready to launch the next day, they still have the delivery cycle of getting product to where it needs to be and tracking what it is. As you look through some of those visibility and detection capabilities, this is the it depends slide in regards to the kind of indication from current administration moving towards we need more visibility, we need more detection in these critical infrastructure spaces, we need more active assessments, we need more information sharing and incident response, we need coordination with other USG partners and information sharing and analysis centers. So there's a hunger for data in the OT areas. As companies go out and try to respond to that, they look at the various tools. In one of my tasks working with INL, we were sort of looking at industrial control system OT vendors. And at one point in time, there was 42 different companies that said, we do that. And as you started looking at the different protocols that they actually support and what they can ingest and what they do, it wasn't 42 companies. There was a much smaller list of companies that actually play in this space. But as companies go out and they say, hey, there's these 10 different products we're thinking about, we're going to have to interface with Emerson, we're going to have to interface with Siemens and Schneider and GE and a variety of different industrial control system products and protocols across a plant or a facility. They have to make sure those different tools can consume that data and do something with it. And then there's kind of this maturity graph that I've seen a number of customers purchase a product and then deploy it and then come back and say, oh, that product's terrible. And I ask, well, what are you ingesting? Are you just doing host traffic? Do you have the ability to do network taps? Does your infrastructure inside of that chemical facility support port spanning or mirroring? In most industrial control system environments and Hirschman switches and Stratix switches, they do not support port mirroring or spanning. So you're getting one keyhole view of the data where you're doing a tap, and that's it. If you've upgraded your infrastructure, now you can get more visibility across that environment. If you have more kind of robust capture where you're seeing multiple interface, true visibility for real-time network collection, you can sort of aggregate from one part of a process to another. And then the other side of this is, are you asking people to just add this task on to their current job? Or are you training dedicated people that this is what they understand, this is what they're doing, and this is what they're looking at daily, so they can start to understand what normal looks like? Just like the operators. So the plant operators or the electric system operators or the natural gas or chemical, they look at that data every day, and they can tell when the system is not behaving in the way it should. You need cyber operators doing the same thing. So if you're doing minimal staff changes, minimal training, and you only have some level of visibility, your best path might be a network whitelisting tool that says, we're going to baseline this, and we're going to say this is the normal flow of traffic in the OT environment. The Modbus communications, the Profinet communications, Ethernet IP SIP, this controller talking to this device, these engineering workstations talking to those, and we're going to baseline that. And then the only alert we want to see, because nobody has any time to look at anything else, is when something diverges from that. So when there's a new protocol that comes, or a new device pops on the network, or something happens, there's a controller failover, we don't want to see any other traffic because we don't have people to look at it and they wouldn't understand it. So if that's the case, network whitelisting may be your best tool to go pick. If you're investing in more people that are looking at this routinely and you're getting kind of real-time network collection, looking for known bad, meaning threat behavior analytics, and looking for normal, meaning whitelisting, this kind of tool set in the middle, threat behavior analytics, may be where you live. If you have absolute kind of full visibility and near perfect understanding of how your facility should operate and what it looks like, and you have a extended team, anomaly detection might be the path. Now you're looking for needles and needle stacks. You're saying this is a normal kind of Modbus write, but based on the process, it shouldn't have happened. We don't have any work management tickets. We don't have any change orders. This shouldn't have occurred. So you have kind of integrated visibility to other external systems from how the plant or how the facility is being operated, and then you can overlay that with what actually occurred. Thinking about this from an incident response perspective, again, kind of across the preparation, identification, containment, eradication, those normal steps, but changing these towards an OT specific. So absolutely doing OT specific exercises. How does it fail and what do you do? And do you have the authorities and who would you notify and what types of inventories do you have? The evidence acquisition and the information sharing, there's a number of different OT environments prior to Colonial that had information sharing and reporting notification requirements mandated, and now with Colonial it's coming to a whole bunch of new sectors. The ability to isolate and still operate through the attack in the containment, the kind of control inhibit and manual mode operation at key intertie sites or key facilities, and then kind of working through the how do you respond and bring the system back up in a manner where you can maintain integrity. You need a specific OT incident response plan. You cannot use your corporate IR plan and hope it works in an OT environment. And anybody that you would be calling for help, if you're calling the cavalry and you're expecting them to come and respond, you should be doing joint training exercises with them. So in your facilities, if this event happened, this is what we've tabletopped, this is what we're doing in an active exercise, this is what we would expect in support from law enforcement or from USG. As you look through kind of that continue to operate through, this is where, Colonial has had this happen. During Hurricane Katrina, Hurricane Rita, they've had pipeline impacts previously. Dozens of impacts. The difference is during a physical event of a valve rupture or some type of system impact, they generally know what time it's going to take, how long will it take to fix that facility or to repair that element of the pipeline. During a cyber attack, the integrity restoration question is completely unknown. How far did the adversary go? What did the adversary manipulate? How much time do we need to spend on recovery? Physical events are easy to predict. We look at kind of all the storm restoration and impacts from electric power. We know we're operating a shared system. If we have a hurricane rip through, we're sending all of our crews over to that other site to help restoration. It's this mutual aid effort. We know we're sharing a common system. In a cyber mutual aid, we have stood up the capability to do that. How it would ever work, nobody knows. Because you can watch from a physical perspective a storm roll through, and you know what impacts it left at your system, so you're okay losing your lineman to go help someone else. When a cyber event happens, do you know it's over? Do you know you weren't attacked? Do you know you're not going to be attacked tomorrow? Are you going to be okay losing your cyber capabilities to go help someone else restore? That's where capabilities within a state like National Guard and others would really, really help in these very specific areas, that when there's a force multiplier need for utilities to consume, asset owners and operators and entities to consume, that is an absolute role that should be pursued. Their response was to move to alternate means of delivery, so tanker trucks, and they had to get all kinds of different governors of states to exceed state road limits for weights for trucks. They had to exceed the You can drive for 20 hours straight if you can stay up that long. All the different laws that were in place they had to remove so they can start rolling more and more of these tanker trucks out. They were looking at maritime and they were looking at rail so they can start moving this in case this went on for a month, for 2 months, how they would actually service critical sites, airports, airfields, other locations. As you think about the restoration, kind of the things we're talking about in each one of these systems in each element. So the traditional switches, routers, and servers. That should be something that feels like old home. Like, yeah, we need the firmware, we need the configs, we need the files. Got it. We need the operating systems, we need the patches, we need the applications. Got it. We're doing kind of grandfather, father, child, backups, fulls, differentials, incrementals every day. We test them, we got it. When you move over to the other side, then now you're talking the firmware of the PLCs. That may be a real question. So for security purposes, a number of different vendors have started moving to signed firmware. So do you have the signed firmware for every single device? Not just the firmware. You need it unique to each one of those elements. Is it somewhere where you can get it? So if you went to look at the Ukraine 2016 events, not only did that attack go after the breaker controller, it went after the Siemens Ciprotec digital protective relays, and as the second follow-on element, it went out and looked for those specific file types to delete them all. So anything that was a smart PC at that substation, it was going after all those recovery files from a logic perspective. It's not looking for docs, it's not looking for XLSs and PowerPoints, this isn't a business attack. It was looking at the configs you would go after to recover. The programming software that you would need to do it, the licensing that you would need to load it. Every one of these little hard devices that a control system vendor sells, they have some pretty stringent licensing. Just getting it to work normally is tough. Doing it in a response and making sure you have access to it all, that would be a challenge as well. And then getting into the data. Again, you're recovering the logic. You're not recovering the data states. Same thing for the operator-human-machine interface, and then getting down into the intelligent devices. These aren't just hand-controlled valves. These aren't just electromechanical relays. These are digital devices now that have firmware themselves, and they have configurations themselves. So if you think of what an attack could be that would cause great harm, is going into those devices and just changing a scaling factor and then locking out the config. So it used to be Fahrenheit, now it's Celsius, and it's going to control to that. That could be horrible. You could go after and change a percent. So when you're tuning these valves and they have performance failure over time, what an 80% valve open might look like mechanically 20 years later, you may change that to a 95%. You can go tune all of that and then lock out the configs. So kind of getting down into that level is pretty significant, and ensuring you have the ability to recover or restore it. Last elements here. How much time do we have? Eight minutes. Okay, this will be quick. So just pointing out a couple of different things. So when this occurred, again, this is something that I do not believe Darkseid planned for, that the White House would be talking about them, and this would be a whole of government response. So you had about 9 different organizations involved here. Being involved in pipeline operations, we would have Department of Transportation requirements. We had TSA requirements. We had public health and safety requirements. We had DOE requirements. Because it's going across interstate, you're dealing with FBI, you're dealing with a number of different orgs. So when you go look at this massive interagency response, and then everything it involves, getting EPA involved for waivers, for the specific quality control on the fuel products, because you no longer have those sensors. You no longer have that data as it's impacted. The DOT hours of service waivers, the governor's expanding weight limits, all of the new things you're trying to do to suddenly transport this product on a ship, on some type of maritime vessel, or over rail. And what that means if now you're moving this highly flammable products on rail through communities where it didn't used to go. In an emergency response effort, this was an absolute whole of government to pull this together within a couple of days. Since DHS has been out communicating with every single pipeline operator saying, we need you to identify who your point of contact is, and they need to be available 24 hours a day, 7 days a week. So this is a rotating shift position that didn't used to exist. Every single pipeline operator needs to have it. That is their point of contact, meaning we need to make you aware of events that are happening rapidly so you can respond to them, and you need to alert us of events that happen as a mandate now. They are now required to start doing some assessments and some gap analysis of their physical and cybersecurity controls. They had to report that back out within 30 days of this event. So the need for people to go do industrial control system assessments and industrial control system cybersecurity is absolutely on the rise in this sector. It is absolutely on the rise in the electric sector across generation, transmission, and control. Again, in the current administration, a memo was released indicating this initiative began with electric. It's now focused on natural gas, and it's coming for water, wastewater, chemical, and others to follow this year. So if you look at that first map that I showed of all 16 of the critical infrastructure, there's indications that they're all going to be regulated soon, and a strong need for people to do assessments and control work within the industrial control system side. These are some of the references that we covered. I believe this is going to be available. Eric, I think I'm told to send you the PowerPoint. The audio is recorded. That is my contact information. I believe we have 3 minutes left, and due to your 1 hour of continuing education, we will fill that 3 minutes. Is there any questions from anybody? So, question for the recording, the level of wireless compromise at the Purdue 0 through 2, so sensor data, actuators into local control and then supervisory control. It depends, will be my first answer. But the pieces, so in Ukraine, a lot of different pathing, meaning most people know that attack from the perspective of the video that was shared. Adversary connected in, got into a workstation, took over mouse. That was 2 of the 3 organizations. A third organization, that is not how it was done. Pathing was established through routes, and they were directly operating the field devices from an external location. So there was a lot of reliance on communication paths in their service territory from internet service providers and others. So when you're talking cellular and you're talking kind of some of their 3G routers that were impacted and direct firmware attacks, that might be one way to look at wireless. On the other side, inside of a plant, inside of a facility, wireless HART is everywhere. We're not running fiber from one end of a plant to another and up continuous emission smokestacks and everywhere where we got to have it. Wireless HART is the path of least resistance. But we're also doing weird things with RF and like train controls and delivery of fuel to a site or remote operation of a valve that's delivering natural gas. So those are all areas of concern. Within the electric sector, we are required to do wireless assessments every 18 months in a active level, like what do we have and where is it, and every 36 months with an with a passive kind of tabletop level every 36 months with an active. So going out and actually doing assessments, looking for rogue access points. If I had to say which is most common, it's going to be some wireless access point into an enterprise and then working across that enterprise and down. That would be the most prevalent. Yes? For sure. Yep. You don't work for SANS, do you? All right, so the question was, as part of the assessment or part of the effort looking at training the individuals there, I'll talk not from a SANS hat, but from a regulatory perspective. Within nuclear and within electric sector, it is required to do every quarterly training specific to their role and every 18 months specific to an individual. If you do not receive that training, you can no longer work in that area and perform those job roles. Same things with the operators that sit at the desk. So they have 200 hours of continuing education required every 3 years, 32 hours of emergency operations. If they don't pass it, they're out. So including cybersecurity for operators and including mandated cybersecurity for specific people with physical access or authorized electronic is required in those sectors. Like Predict and Sunrise, I will tell you those requirements from electric sector and nuclear are going to be coming for the rest. Yep, so threat analytics, question on once you have the blessing where you can actually see OT data. So you go into a facility, there's no managed switches, so you're blind. So you can tap out of one point and sort of see it, and now you see data that you don't have Wireshark dissectors, you have no idea what normal looks like. What does that look like from a threat analytics perspective on the IT, where you can sort of model an adversary actions? What does that look like on an OT side? So it's definitely diminished, meaning the visibility is hard in a facility, and then the capabilities of the tools are really what's coming. So in the fixed deterministic environment, meaning a water treatment facility, the way a controller talks to a process and the way the engineering workstation talks and going through normal operations and emergency operations and forcing controller failovers and getting that all in a baseline, that is a wonderful way to start watching, where you're just looking for deviations. That's it. Going into an electric power site where we used to be 100% hands-off and not touch a thing, that is not that way anymore. They are not deterministic, stable, low interaction environments. They are high interaction environments. We are looking for patches. We're looking for user modifications. We're doing system hardening, ports and services, local firewall rules, everything you can think of, logging, alerting on a real-time basis, 15-minute reviews, and then we're doing security patching and updates every 30 days. So those are no longer great places for whitelisting. You're constantly changing it, so you would just be filled with alerts. So depending on the sector, the answer is different. If you have no staff to sort of filter through all the things that are happening, a lot of things in a control system environment look like attacks. That is just it operating. In that model, going down behavior analytics, where you're saying we're taking whatever we can baseline, we're taking whatever we can ingest from a log and an event analysis, but we are also layering in historian data. We're also layering in configuration data. We're looking at this tool from Siemens talks to that product, and it can tell if a control point has changed. That's what an operator sees, but now some of these tools that are coming on the market can ingest that as well. They can ingest historian data. So you're starting to also include sequence of event data and process data, not just endpoint, hey, there was an intruder, an unauthorized login. You're looking at there was this event and there was this process event. So you can sort of correlate something that shouldn't have happened and when it happened. The behavior analytics side also layers in other attacks that have happened, which look like looking at the FireEye Darkseid, how did they get into the corporate? Companies like a Dragos, like an Indigi, like a Nozomi, they are looking at how did they get into an OT environment? Did they come east-west? Did they come north-down? What protocols are they using and what are they doing? Is it OPC scans where they're pulling data in? And why is that happening from a remote IP? Those types of behaviors it'll trigger on. The other tools that are more anomaly detection, they will 100% detect everything. It's a question of whether your operator knows that something bad happened and what actions to take. So it is absolutely maturing, but we're along for the ride. It's maturing in every way, meaning the sensors, the digital devices, the capabilities of the tools, the capabilities of the operators, and then what other systems they can merge them with. It'll probably be 4 or 5 years before we feel good about it. Any other questions? I think we are exactly on time, so thank you for coming. I appreciate it. Have a good day.